So where y is defined in terms of x. So as you see those explicit equation examples, y equals the square root of x squared plus 1, y equals x plus 2, or y equals x times the sine of x. So we've always been used to explicit equations. Well, now we are going to be given implicit equations and told to find the derivative with respect to x. So what's great about implicit differentiation is that you don't have to rearrange the equation in terms of y. All we're going to do with an implicit equation is take the derivative, the implicit derivative with respect to x, and then solve for the derivative y prime. So implicit derivatives actually make our life easier because on certain equations, you're not going to be able to solve for y. So that's why we just take the derivative, we take the implicit derivative and solve for y prime. So implicit derivatives make our life easier. Okay, and I think that's what that whole paragraph said, or whatever I just said. Okay, so a couple of notations of what I use and WebAssign uses and the book uses. I like to keep the notation simple. So whenever you are taking the implicit derivative of y, you're going to see that the implicit derivative of y is going to be y prime. And then the implicit derivative of y squared is going to be 2y prime. And the implicit derivative of y cubed is going to be 3y squared y prime. But let me dive a little bit more into notation of why this is. Okay, look at this. Bam, bam. So when I say d over dx of y, we get a notation such as dy over dx. Now this notation is important because you'll see it definitely in Cal 2 a lot. This is called the Leibniz notation. And it's what the answers will use and some of the answers won't use. The reason I don't use it because I just like it, the paper being clean, and having these dy over dx's everywhere just looks messy. Okay, but that's the name of the notation. But what we're going to use, which is similar, is dy over dx. The derivative of y with respect to x is just going to be y prime. Look how much neater that is. Okay, so this is what we're dealing with implicits. And it would go so on and so forth for the other ones. So if I were to write d over dx of y squared, you would have, what is it? Oh, it's going to be 2y dy over dx, or 2y y prime. So just showing you the differences of notation, but just know they mean the same thing, and we will be using the prime notation today. Okay. All right, which means let's go ahead and get started. So for number 1, it says use implicit differentiation to find y prime for the given equations. Okay. So the way we do this, oh, sorry. Okay. Working with the new OneNote today, is when we take the implicit derivative, we're going to say d over dx of 5x cubed minus y minus 1 equal to d over dx of 0. So we apply the implicit derivative to both sides with respect to x. Okay. And then we take the derivative of 5x cubed, which is going to be 15x squared. We take the implicit derivative of y with respect to x, and you're going to get negative y prime. And then we know that the derivative of negative 1 is 0, and the derivative of 0 is still 0. So here is our implicit derivative, and all we have left to do is solve for y prime. So simple enough, just add that y prime to the right side, and we have our derivative. So you'll get 15x squared equal to y prime. Okay. Any questions on that? All right. Okay, let's try another one out. That one seemed too easy, right? Okay, so let's do it again. And we're going to say d over dx of y squared plus x cubed plus 4 equal to 0. Nope, not equal to 0. I need that d over dx, sorry. D over dx of 0. And then we're going to take the implicit derivative of y squared, which means that the implicit derivative of y squared with respect to x is going to be 2y y prime plus the implicit, not the implicit, sorry, just the regular derivative of x cubed, 3x squared, derivative of 4 is 0, and derivative of 0 is still 0. Okay. So there's our derivative. Now, all we have to do is solve for y prime. So that means move that 3x squared over. So you'll get 2y y prime equal to negative 3x squared. And then to solve for y prime, just divide by 2y, and you'll get y prime is equal to negative 3x squared over 2y. Okay. And there's our derivative. Okay. Any questions on that? Nice. Oh, go ahead. No, go ahead.
Whenever you have 2y of y prime, do you have to do it in a fraction every time?
What do you mean fraction?
Because you put it negative 3x squared over 2y.
Yes, because we're solving for y prime.
Oh, y prime. Okay, my
We're
bad.
solving for y prime, so we divide off the 2y.
Oh, okay. Oh, I see it. I see it. Thank you.
Okay. And the reason I said that implicit derivatives make our life easier, well, let's go ahead and explore why. So look at this problem and let's go ahead and solve it for y. So if I solve this for y, I'd get y squared is equal to negative x cubed minus 4. And then I'd square root both sides and get y equals the square root of negative x cubed minus 4. So what we have just done is taken an explicit and put it back into implicit form. And now we want to take the derivative of this explicit equation, which means that we would have to rewrite this as negative x cubed minus 4 to the 1/2. And now when you take the derivative, you have to use chain rule. So the derivative of this would be 1/2 times negative x cubed minus 4 to the negative 1/2 times the derivative of the inside, which is negative 3x squared. Okay, this is already looking more difficult than what we see on the left side, but let's go ahead and finish it up. And the way I can rewrite this final derivative is as negative 3x squared over 2. Go scroll up a bit. Okay. As 2 times negative x cubed minus 4 to the 1/2. And believe it or not, these two answers are equivalent. Now tell me which one you like the best, the left side or the right side?
The left side, obviously.
The left side, obviously, right? But again, you can see why these are equivalent answers is because what we did earlier was, well, we rearranged for y. So all of this is just y, because that's what we put right there. Or right there. Crazy, right? So implicits make our life a little bit easier. Not bad, huh?
That actually really helped because with you just telling us this equals this, it kind of like I believe you, but like
but now
give me
you
the
see the
proof,
connect.
dude.
Now you see the
Yes.
connection, right?
Okay. Thank you.
Mhm. Yeah. We can say that. We can even let's see. There you go. That's why. That's why. That's why. But now you see why implicits make your life a little easier. Okay. Any questions before moving on that one? All right. All right. Well, let's try it again. Number 3. Do the implicit derivative. And purple. So say d over dx of y squared minus y minus 4x equal to d over dx of 0. Okay. Now we're going to do implicit derivatives of y squared and y. So this means I'll get 2y y prime minus the implicit derivative of y, which is y prime, minus the derivative of 4, negative 4x, which is just negative 4, equal to 0. Okay. And now, after you take the implicit derivative, your goal is just solve for y prime. So this means move that 4 over, and we'll have 2y y prime minus y prime equal to 4. And then to solve for y prime, you notice that what could you factor out on the left side?
Y prime.
Y prime. Factor out a y prime, and you'll get 2y minus 1 equal to 4. And then all you have to do to solve for y prime is divide by 2y minus 1. So this means that y prime would be equal to 4 over 2y minus 1. Scroll up. There we go. Okay. So take the implicit derivative and solve for y prime. That's all you have to do. And if, of course, it's not taking the y prime notation, then remember that you can also write dy over dx is equal to 4 over 2y minus 1. Okay, all good on that one? Cool. All right. Keep moving. Okay, 4. Same thing here. I need to change up my colors a bit. Oh, well. Oh, there's blue. Okay. So same thing, we're going to say d over dx of 3xy minus 2x minus 2 equal to d over dx of 0. Okay, so here we have to take a brief second to pause, because when we apply the implicit derivative to 3xy, this is going to use an important rule. Because now, since this is an implicit equation, this means that x and y are their own separate functions, which means that x times y, when you take the derivative of a function times a function, this is going to use the product rule. But now it's going to have to change it up a bit, because this is going to use an implicit product rule. Oh, just terrible, right? So this will use implicit product rule, which means that f will be x and g will be y. Okay, still red. So now with the implicit product rule, using product rule, we take the derivative of f and the derivative of g. Well, here f prime is 1. And now over here on g, remember that we are taking the implicit derivative. So this means that g prime will be equal to y prime. Okay, and now let's just go ahead and finish up this product rule, which means you're going to have f prime g, and I'll put this over here, hang on, implicit product rule of x, y, and f prime g, that's going to give you y plus g prime f, which you can put as y prime x, but I like to write it as x, y prime. There we go. So go ahead and save this somewhere to save you some time in case you ever see that you need to take an implicit product rule of x times y. This will always be the formula. Okay, now we can get back to our derivative. So let's start again. We're going to have 3 times my implicit product rule, I'll put it in red, of y plus xy prime minus the derivative of 2x, or negative 2x, which is negative 2. Derivative of negative 2 is 0, and derivative of 0 is still 0. Okay, now all we have to do is solve for y prime. So distribute that 3y plus 3xy prime, and I'm going to move that 2 over already. Let's just knock that out of the way. Equal to 2. Okay, solve for y prime. That means move the 3y over to the right side, and you'll have 3xy prime equal to 2 minus 3y. And then all you have to do from here to solve for y prime, just divide by 3x. And y prime is going to be 2 minus 3y over 3x. There it is. All right, implicit product rule, huh? Okay. Any questions on that one?
No.
Cool. All right. Everybody's good. Okay. Yeehaw. All right. 5. We're going to do it again. 2x cubed y minus x cubed plus 5 equal to 0. Take the implicit derivative. All right. And I'll go back to black. Sure. D over dx of 2x cubed y minus x cubed plus 5 equal to d over dx of 0. Okay. Again, we have to pause for a second because we need another implicit product rule here. So this is going to use another implicit product rule. Of x cubed y. Okay, this means that f is going to be x cubed, g will be y, derivative of f is 3x squared, derivative of g, implicit derivative of g gives me y prime. Okay, and then I guess we can create another little formula here. F prime g, we get 3x squared y plus g prime f x cubed y prime. There we go. All right. So now we can continue with our derivative. Two times, and then I'll put in there the 3x squared y plus x cubed y prime, and then minus the derivative of x cubed, so negative 3x squared, and then 0, 0, and 0. There we go. Okay, so again, after you take the implicit derivative, solve for y prime. So we're going to distribute that too. So we should get 6x squared y plus 2 x cubed y prime. I'm going to move that 3x squared over already. So you'll get equal to 3x squared. Okay. And then, of course, we're solving for y prime. So now we're going to move that 6x squared over to the right side. 6x squared y. So this means we'll have 2x cubed y prime equal to 3x squared minus 6x squared y. And then we can divide by 2x cubed. So if we do that, we'll have y prime equal to 3x squared minus 6x squared y all over 2x cubed. Okay, so this one, unlike the others, we actually have a chance to simplify. What could you factor out of the numerator?
X squared or 3x squared.
You can take a 3x squared out. That'll work. And that'll leave me with 1 minus 2y, right? Over 2x cubed, which means that we get to reduce again. And we know that this x squared will cancel. This x cubed will reduce to x to the first, which means that we'll get our final answer of y prime equal to 3 times 1 minus 2y over 2x. There we go. All right. Everybody good with that?
Yes.
Cool. All right. All right. We're moving. We're moving. Okay. 6. Ooh, that's a fun one. All right. Sine of x plus y equal to y squared times the cosine of x. All right. So here we'll apply the derivative to both sides. D over dx of the sine of x plus y equal to d over dx of y squared cosine x. Okay. So the left side, sine of x plus y, this is going to use an implicit chain rule. So this is going to be implicit chain rule. So when we do the implicit chain rule, well, we look at the outside function. What is the derivative of sine?
Cosine.
Cosine. So you'll get cosine x plus y, that's the derivative of the outside, times the derivative of the inside. Well, now you're taking the derivative of x plus y. And so that means that the derivative of x is 1. And the implicit derivative of y is going to be y prime. That's the derivative on the left side. Okay. Which means on the right side, y squared times the cosine of x, what rule are we going to have to use?
Product rule.
Product rule. So implicit product, right? Okay, so I'll just write this out to the right side. And we're going to get f is y squared. G is the cosine of x. Take the derivative of f, which is going to be implicit derivative. So 2y, y prime. Take the derivative of cosine, which is negative sine x. Okay. So all we have to do now is finish up our product rule, and you'll have f prime g, which is 2y, y prime times the cosine of x, plus g prime times f, which is going to be y. So it's going to be negative, but I'll say plus negative y squared sine of x. Okay, let's look at what we have. Oh, just ugly, right? Okay, so remember, our goal is to solve for y prime. So now we have to figure a way to put our y primes together. Let me just rewrite it because I hate that negative sign there. It just bothers me. So I'm just going to rewrite it one more time as cosine of x plus y times 1 plus y prime equal to 2y y prime cosine x minus y squared sine of x. Okay, so the right side we're good on. The left side we have to clean up. So over here we have to clean up. So what do you think we can do here? How do we get this y prime? How do we get this y prime out of that parentheses?
Divide by cosine of x plus 1.
Let's see. So if I divide by cosine of x plus y, what does that do to the y prime on my right side?
Oh,
Do you trap it?
I don't know.
So if
Yeah.
you divide, it's a good thought. So if you divide by cosine x plus y, you trap that y prime on the right side, and our goal is to solve for y prime. We don't want to trap it. So what would be another option?
Just leave it like that.
Yes,
Will it?
leave it like that and go ride your scooters. Yes.
Mhm.
What is one of your favorite things to do as a math student?
Conjugate.
No.
What do we distribute?
You distribute.
Oh, yay!
You would take cosine x plus y, and you would distribute it to the 1 and to that y prime. The whole thing, cosine x plus y, not just x and y. It has to be the cosine x plus y. So what that looks like is, well, cosine x plus y times 1 is just cosine x plus y. Plus cosine x plus y times y prime gives me y prime cosine x plus y equal to all this nastiness over here. Okay, and now all we have to do is put the y primes together. So I'm going to take 2y y prime, move it to the left, and I'm going to take cosine x plus y and move it to the right. So what we have is y prime cosine x plus y minus 2y y prime cosine x equal to, and everything's going to be negative, right? Yes. So you'll have negative y squared sine of x minus cosine x plus y. Ooh, ugly. But it's a good time. Okay. And now remember, after all of this mess, we're still solving for y prime. So what could we do on the left side?
We can factor out the y prime.
Take out that y prime. Factor out the y prime, and I'll put a bracket here to be neat. just for neatness, and we'll have cosine x plus y minus 2y cosine x, close the bracket, equal to negative y squared sine of x minus cosine x plus y, and then just divide by all of that. And you'll get y prime equal to negative y squared sine of x minus cosine x plus y over cosine x plus y minus 2y cosine x. Read it and weep. Don't cry too much though.
That was rough.
A little bit, but I mean, the only calculus, like where the calculus ended was right here. Everything past the zero was strictly algebra. Distributing, combining like terms, factoring, dividing. So once you get that implicit derivative, it's just algebra from there on out. So the calculus part, that was easy, right? Maybe. Okay. Any questions on that one?
I have a question.
Go ahead.
So will we ever run into an equation where y isn't a fraction or under a square root, maybe?
Yeah, you may run into one such, let's say if it was, let me see, can I write? Yeah, let's say if it was like x plus y equaled x plus y to the 1/2, then yeah, you can run into, you can get an equation like this, but remember, all you have to do is solve for y prime. So there's no reason to rearrange the original problem for y. That's why we use implicit to make the work easier. So we could take the derivative of this equation and then solve for y prime. So as long as you're solving for y prime, you're good. That answer your question? Okay. Any other questions on this one? Everybody just soaking it in still? Oh yeah, because I think that's it. Yeah, we're done. So if you got questions about these notes, stick around. You got questions about the homework, definitely stick around. Other than that, we are done. That is implicit differentiation.
You want to do 2.516 for me?
2.5